Okay, hello everyone in a new video. So in this one we are going to complete the explanation of chapter 2, which is the chapter of formation of images in the first unit, which is the unit of optics. So we have reached section 11, which is the construction of the optical center. So 11.1 first case, real image. Okay, here we have document 1. Number 1, they are telling me the direction of the image A prime, B prime. So in this document we have the object AB, and we have the image A prime, B prime. We don't have the lens, and the direction of propagation of light is taken to be from left to right, okay? And they are asking me about the direction of the image with respect to the object, so we need to say whether it's inverted or erect. Notice that here the object AB is pointing upward, and the image A prime, B prime is pointing downward, which means that the image is in opposite direction with respect to the object, which means it is inverted. Then let's say that the image A prime, B prime is inverted with respect to the object AB. Now in number 2 they are telling me the nature of the image A prime B prime, so we need to indicate whether this image is a real one or virtual. So here, because the image is inverted with respect to the object, then the image is real, because we know that always a real image is inverted with respect to the object. Then let's say that since it is inverted with respect to the object AB, then the image A prime B prime is real. However, in this case, we cannot say that the image is real because the object and the image are on opposite sides, because yet here we don't have the lens, okay? Now, in number 3, they are telling me construction of the optical center and placing the lens cell. And the word construction means that we need to trace and justify at the same time. Therefore, we need to trace the optical center and justify the tracing. So here, if we connect the point B and B prime like this, so the intersection between the line BB prime and the optical axis will be the optical center O. So BO corresponds to an incident luminous ray, so we don't forget arrows on light rays, and OB prime will be its emergent ray. Then O is the optical center, because we know that an incident ray issued from B passing through the optical center emerges without deviation. In other words, that the points B, O, and B prime belong to the same straight line. Then let's say join B and B prime. The intersection of BB prime with the optical axis and this is because an incident ray issued from B emerges without deviation. Now in the same part they are telling me to place the lens L. So we all know that the lens L is perpendicular to the optical axis at the optical center O. So this is the lens L. But now we need to indicate the nature of the lens in order to use the correct symbol. So notice that here, because the image is real, then the lens L is a converging lens, because we know that only a converging lens can give a real image. So this is it for this section. Now we are going to see the construction of the optical system, of the optical center, but in the case of a virtual image. Now here in number 1 they are telling me the direction of the image A prime B prime. So notice that the object AB is pointing upward and the image A prime B prime is also pointing upward, which means that the image and the object are in the same direction, which means it is erect with respect to the object AB. Then let's say the image A prime B prime Now in number 2 they are asking me about the nature of the image A prime B prime, and in this case, because the image is erect, then it will be virtual, because we know that always a virtual image is erect with respect to the object. Then let's say since it is erect with respect to the object AB, then the image A prime B prime is virtual. Also here we can give the same remark. We cannot say that the image is virtual because the image and the object are on the same side, because yet we don't have the position of the lens. And now in number 3 they are telling me construction of the optical center and placing the lens L, and the word construct means that we need to trace and justify at the same time. So first let's do the tracing. Now if we join the 2 points B and B prime, so the intersection between BB prime and the optical axis is the optical center O. So this is the optical center. Now BO is an incident ray issued from B passing through the optical center, and this is the emergent ray corresponding to the incident ray BO. Notice that this line must be dotted because it's the prolongation of this emergent ray. So the optical center O is the intersection between the line BB prime and the optical axis. So let's do the justification. Join B and B prime. The intersection of BB prime with the optical axis is the optical center. This is because an incident ray issued from B emerges without deviation. Passing through the optical center emerges without deviation. So now, now we know the position of the optical center. Then the lens L will be perpendicular to the optical axis at the optical center O, like this. And now in order to use the convenient symbol of the lens L, we need to indicate or specify its nature. And the nature of the lens can be determined from its role. So here the image A prime B prime is larger in size because it consists of 1, 2, 3, 3 divisions, whereas the object AB consists of 1 division. So the image is larger in size. And we have justified that the nature of the image is virtual, and we know that whenever the image is virtual and larger in size, then the role of the lens is a magnifier, and we know that only a converging lens can play the role of a magnifier. And now let's move to the next section. So in section number 12, construction of the image focus. So in section 11, in the previous section, we have constructed the optical center. So now we will learn how to construct the image focus of a given lens. So let's start by the first case, which is the case of a real image. Here in this document we have the object AB and we have the lens L, and we have the image A prime B prime given by the lens L of the object AB. But in this case we don't know the position of the object focus or the image focus. So the aim of this section is to construct the image focus. And number 1, they are asking me about the nature of the image A prime B prime. So in this case, the image A prime B prime is real. So the object AB is pointing upward and the image A prime B prime is pointing downward, which means that the image is inverted with respect to the object. For this reason, it is real. Then we can say it is, or since it is inverted with respect to the object AB. One could give another reason why the image is real. Notice that the object AB is in front of the lens, and the image A prime B prime is behind the lens, and whenever the object and the image are on opposite sides, then the image is real. Since the object AB and the image A prime B prime are on opposite sides. Now in number 2, they are telling me construction of ray issued from B and parallel to the optical axis. The word construct means that we need to trace and justify at the same time. So this is an incident ray issued from B parallel to the optical axis. We know that always incident parallel ray is related to the image focus. But however, in this case, we don't know the image focus. We know the image B prime of B, and we know that all incident rays issued from B emerges going to B prime. And we don't forget arrows on light rays that indicate the direction of propagation of light. So this is the tracing. Now let's do the justification. Then this ray is issued from B. Emerges going to B prime. Now in number 3, they are telling me construction of the image focus F prime. First, let's trace the image focus F prime on the document. So because this incident ray is parallel to the optical axis, then its emergent ray will be related to the image focus. Then the intersection between this emergent ray and the optical axis will be the image focus F prime. So this is the image focus F prime. Now let's do the justification. Then the image focus F prime is the intersection between, so let's say it's the intersection of the emergent ray with the optical axis. Now finally, in section 12.2, second case, the case of a virtual image. So we need to construct the image focus. Let's start by number 1, the nature of the image A prime B prime. In this document, the direction of propagation of light is taken from left to right. We have the object AB. We have the image of the object given by the lens L. However, the position of the object focus and the image focus are not given. And number 1, they are asking me about the nature of the image. So here the object AB is pointing upward and the image A prime B prime is pointing upward, which means that the image and the object are in the same direction. And whenever the image and the object are in the same direction, which means it is erect, then the nature of the image is virtual. So virtual, since it is erect with respect to the object AB. One could give another reason why the image is virtual. So notice that the image and the object are in front of the lens on the same side, and whenever the image and the object are on the same side, then the image is virtual. Since the object AB and the image A prime B prime are on the same side. Now in number 2, they are telling me construction of a ray issued from B and parallel to the optical axis. So this is a ray issued from B parallel to the optical axis. We know that this ray will emerge passing through the image focus, but in this case we don't know the image focus. However, we know the image B prime of B. Then this ray will emerge as if coming from B prime. So let's connect the point B prime with the point where the incident ray hits the lens. Therefore, this ray will emerge as if coming from B prime, like this. And we don't forget arrows on light rays that indicate the direction of propagation of light. Now let's do the justification. An incident ray issued from B parallel to the optical axis emerges as if coming from B prime. Now finally, in number 3, they are telling me construction of the image focus F prime. So since this incident ray is parallel to the optical axis, then its emergent ray will be related to the image focus, and we know that the image focus belongs to the optical axis. Then the point of intersection between this emergent ray and the optical axis will be the image focus F prime. So this is the tracing. Now let's do the justification. Then the image focus F prime is the intersection of the emergent ray with the optical axis. So now section 13, properties of the image given by a converging lens. So let's write here number 1, referring to documents 1 and 2. So here in document 1, the direction of propagation of light is from left to right, x prime axis the optical axis. We have the converging lens L perpendicular to the optical axis at the optical center O. And F and F prime are the foci of the lens. F is the object focus, F prime is the image focus. And now AB is a luminous object placed in front of the lens. Now the number of divisions between the object AB and the object focus F are given by 1, 2, 3, 4. So 4 divisions between the object and the object focus. Now these two rays are incident rays issued from B, and these are the emergent rays corresponding to these two incident rays, and A prime B prime is the image of AB given by L. And here in document 2, now the same object AB is being placed one division away from the object focus. So now as we can notice that the object AB is closer to the object focus, then let's write down as the object AB approaches F. And the word approaches means getting closer. So now the object AB is closer to the object focus F. Now here in document 1, the distance D, which represents the distance between the lens and the image, consists of 3 divisions. Whereas when the object AB is closer to the object focus, this distance D, which is also the distance between the lens and the image A prime B prime, consists of 1, 2, 3, 4, 5, 6 divisions. And as we can notice that whenever the object AB is closer to the object focus, this distance D, which is the distance between the lens and the image, increases. Then we can say as the object AB approaches F, the distance lens image. So this distance is the distance between the lens and the image increases, which is denoted by D here. Also, we can notice that as the object AB approaches F, here in this case when the object AB was at 4 divisions away from the object focus, the size of the image was given by 0.5 divisions. And when the object AB is placed 1 division away from the object focus, the image A prime B prime consists of 2 divisions. Then we can claim that also that as the object AB approaches F, the size of the image And finally, the last thing that we can notice from or by comparing these two documents, that whenever the object AB is placed in front of the object focus, then the nature of the image will be real, because we know that a converging lens give a real image and a virtual image, and this depends on the position of the object. Then we can say that since the lens L is a converging lens, and the object AB is placed in front of the object focus, then the image A prime B prime is real. And now we are still in the same section, which is the properties of an image given by converging lens. Now, idea number 2. So here, referring to document 3, now notice that the object AB is placed between the object focus and the optical center. And in this case, the nature of the image is virtual because the object AB is pointing upward and the image A prime B prime is pointing upward. So the image is erect with respect to the object, which means it is virtual. And this is because now the object AB is placed between the object focus and the optical center. So let's say since the lens L is a converging lens, and the object AB is placed between the object focus and the optical center. Then the image A prime B prime is virtual, and we know that always the image, the virtual image given by a converging lens is larger in size. So let's write down and larger in size. And finally, the last property concerning a converging lens. So notice that here in document 4, the object AB is now being placed at a distance P. So this is the focal length, and we know that because f and f prime is symmetric with respect to O, so also f will be separated by distance equal to f. So this is also equal to the focal length, and this is equal to the focal length. So in this case, P is equal to the double of the focal length. So now the object AB is being placed at the distance P, which is the double of the focal length. So here the focal length is given by 2 divisions. So in this case, the object AB is being placed at the distance given by 4 divisions away from the lens. So if this is f, this is also f, this is f, so P is equal to the double of the focal length. And in this case, because P is equal to the double of the focal length, the first thing that we can notice is that the object AB consists of 1 division, and the image A prime B prime consists of 1 division as well. So the object and the image are equal in size. Moreover, the distance P prime, which is the distance between the lens and the image, also is equal to the double of the focal length, because this is equal also to the focal length. Then we can say that, referring to document 4, this is also f, referring to document 4, the object AB is placed at a distance P is equal to 2f in front of the lens. So since P is equal to the double of the focal length, then the size of the object is equal to the size of the image. So this is the first rule. And the second rule is given by and p is equal to p prime. So the distance between the object lens is equal to the distance lens image. And in this case, because the image is real, so we have a real image, and because the size of the image is equal to the size of the object, so equal in size, then the role of the lens in this case is a photocopier. So in this case, we obtain a real image. Let me write a real clear image. And it can be formed sharply on a screen. In this case, the screen may be a piece of paper. Okay, so the idea behind this property, which is property number 3, is that we have 3 rules, and they are given by p is equal to 2f, ab is equal to a prime b prime, and p is equal to p prime. So these are the 3 rules. So whenever we have one of them, for example, if we have p is equal to 2f, so we can directly in the exercise use either this or this. For example, if we have that the size of the object is equal to the size of the image, then directly we can use this formula or this formula. Okay, for example, if we have that the size of the object is equal to the size of the image, and we know already the distance between the object and the lens, which is given by p, then from this relation we can deduce the focal length. So this is another method in order to determine the focal length of a converging lens. Now finally, in section 14, nature of the image. So in this table we have the properties of the real image and the virtual image. So now we know that if the object and the image are on opposite sides, then the image is real. If the image is also inverted or collected on the screen. Now if the object is placed in front of the object focus, then the lens is a converging lens, then the image will be also real. And if the emergent rays are converging, if they intersect at a certain point, then in this case the image will be real. Now in the case of the virtual image, if the object and the image are on the same side, if the image is erect, if it cannot be collected on the screen, if the object is placed between the optical center and the object focus, and the lens we are using is a converging lens, if the emergent rays are diverging, they don't intersect behind the lens, therefore we need to prolongate them backward, and in this case the image will be virtual. And if the lens that we are using is a diverging lens, because we know that a diverging lens gives a virtual image. And now finally let's talk about the role of the lens. So from chapter 1 we have started by the lens, and we have classified it as a converging or a diverging lens. Then later we have seen that a converging lens can give a real image and a virtual image at the same time, whereas a diverging lens only give a virtual image. So what's the difference between the virtual image of a converging lens and a diverging lens? So the virtual image given by converging lens is larger in size, whereas the virtual image given by diverging lens is smaller in size. So for this reason, one of the roles of a converging lens is a magnifier, whereas the diverging lens only has the role of a peep door viewer. And in the case for a real image, we also have 3 cases, and they are given by larger in size, equal in size, or smaller in size. And whenever the image is a real image and larger in size, then the role of a lens is a projector. Whenever the image is a real image and equal in size, then the role of the lens is a photocopier. And whenever the image is real and smaller in size, then the role of the lens is a camera. So that's it for me in this video, guys. In the next part, we'll solve exercises related to this chapter.